Okay, so I'm just going to jump around a bit with the order of the example. This is just because it makes more sense. It's much easier to do the examples later on. So I'm going to jump to example 19 first, so over on page 11. Because example 19 is just a direct proof, right? So it starts off by saying, if a series of numbers are consecutive, so one after another, then we can write them as, if n's my starting number, then n plus 1 is the number after, and n plus 2 is the number after that, etc., right? So example A says, prove that the sum of 3 consecutive natural numbers is equal to 3 times the middle number, all right? So part A. So we want to show that the sum of 3 consecutive numbers, natural numbers in fact, is equal to 3 times the middle number. Okay, so let's start off by defining our numbers, right? So let n equal our middle number, where n is some value in capital N, our natural numbers, right? What does it mean in terms of consecutive numbers? So we want 3 consecutive numbers where n is the middle value. So that means the number before is n minus 1, because we're talking about whole numbers, and the number after that is n plus 1. Right, so we want to show that if we add n minus 1 and an n plus 1, then it's equal to 3 times the middle number. So what's our goal? We want to prove that n minus 1 plus n plus 1 is equal to 3 lots of the middle number, which is 3n. So let's prove this. So proof, well, sum of the 3 consecutive numbers, well, n minus 1, because our first consecutive is n minus 1, plus the middle number plus the one after is equal to, well, have a look, 1n, 2n, 3n, so that's 3n, and then minus 1 plus 1, that cancels, so oh my gosh, wow, it's 3n. Whoa, who would have thought? So therefore, the sum of 3 consecutive natural numbers is equal to 3 times the middle number. So you start off your proof by defining your variables of interest, write down what you want to show, actually show it. Therefore, your sentence conclusion is what you wanted to prove, what you've accomplished in proving. Let's have a look at part B. We want to show that for A and B in the reals, a squared plus b squared is bigger than 2ab. Okay, so alright, so we want to prove that for a and b in reals, we want to show that a squared plus b squared is bigger than 2ab. Alright, let's prove it. Well, let a and b be in reals. So we've got a and b are your real numbers. Okay, the trick here is to recognize patterns, right? So on the left, you see a squared plus b squared. On the right-hand side, you see 2ab. Where do you see the terms a squared, b squared, and 2ab occur in algebra? Does that ring a bell? How about if I said a minus b all squared? Because if you expand a minus b all squared, what do you get? A squared minus 2ab plus b squared, right? So, what do you know about square numbers? Square numbers always has to be bigger than equal to 0, right? Since all square numbers are bigger than equal to 0. So if a square any number is always positive or 0, right? On the left-hand side, if we expand that, so a squared minus 2ab plus b squared must then be bigger than or equal to 0. If I then rearrange the minus 2ab to the other side, so therefore a squared plus b squared is bigger than or equal to 2ab. Therefore, we've shown that, therefore, for a and b in reals, we have shown that a squared plus b squared is bigger than or equal to 2ab. So here in example 19, the technique we've used to prove the statements are called direct proofs, because you literally just take the statement and manipulate it. Now the question is, how do I know when to use the a minus b all squared, those kind of techniques? It's a matter of exposure. So the more examples and the more techniques you observe, the more you remember it and store it in your prove toolbox. Because sometimes it might just be as easy as literally, I write down 3 consecutive numbers and wow, I added up and it's literally my answer. Sometimes you need to think about, well, where have I seen this pattern before in algebra? How can I manipulate it? Well, and then using the fact that all square numbers are always 0 or bigger than 0, a positive, and then manipulate your expression so that you get the statement you want to show. So it's all about looking exposure. So if you've seen it before, just remember, jot down these little techniques, and yeah, just